In a quiet hotel room in New York, long after the applause had faded, Nikola Tesla still imagined the world in currents. Outside the window, the city was already glowing with the kind of electrical life he had helped make possible. Lamps burned in offices and apartments. Elevators moved through tall buildings. Motors turned invisibly inside machines. Signals crossed distances that would have seemed almost magical a generation earlier. The modern world was beginning to hum in the dark, and yet the man who had dreamed so much of it was living alone, increasingly remembered less as a builder of that world than as a strange figure at its edge. Tesla's story is often told as a simple tragedy of stolen credit. A lonely genius sees the future. Other men take his ideas, and history gives them the applause. There is truth inside that feeling, but the real story is quieter, more complicated, and in some ways, more haunting. Invention does not pass directly from a mind into memory. It passes through laboratories, contracts, patents, investors, newspapers, courtrooms, factories, public demonstrations, and the names that institutions choose to repeat. Tesla had one of the most remarkable imaginations in the history of technology. He could picture machines before building them. He could think in systems, not only in parts. He helped give the world alternating current power, explored invisible forces, demonstrated wireless control, and dreamed of a planet connected by energy and communication. But he lived in an age when ideas needed more than brilliance to survive. They needed companies. They needed money. They needed timing. They needed public trust. And Tesla, for all his gifts, was never fully at home in that machinery of ownership. This is not only the story of a man forgotten while others took credit. It is the story of how the future becomes someone's property, how memory attaches itself to certain names and lets others fade, and how a visionary can illuminate the world without securing his own place inside its light. When an invention changes civilization, who truly owns it? And when the world begins to use a dream every day, what happens to the dreamer? There is a strange kind of darkness that can exist even in a world full of light. It is not the darkness of a room before a lamp is switched on, or the darkness of a street before the first electric signs begin to glow. It is the darkness that gathers around a name after the work attached to it has already entered ordinary life. The machines continue running. The wires remain hidden in the walls. The current keeps moving. But the person who first helped imagine that world can become harder and harder to see. Nikola Tesla belongs to that kind of darkness. His name now feels almost impossible to separate from electricity. Genius lost inventions, and the strange romance of the misunderstood visionary. For many people, he stands as the great forgotten inventor, the man whose ideas were used by others, whose brilliance was overshadowed by men with better business instincts, louder reputations, stronger institutions, or more durable public myths. Yet this modern image, powerful as it is, can also blur the man himself. It can turn him into a symbol so bright that the historical Tesla disappears inside the glow. The real story is not as simple as a genius robbed in a single dramatic act. It unfolded more slowly through a world that was learning how to turn invention into property. Tesla lived at a time when electricity was changing from a mysterious force into a commercial system, and that change required more than insight. It required laboratories, patents, contracts, investors, factories, newspapers, public demonstrations, lawsuits, and the ability to keep a name attached to an idea after the idea had become useful to everyone. That was the world Tesla entered. It was a world of glowing bulbs and dangerous wires, of industrial ambition and public fear of men who understood that a new technology did not simply need to work. It needed to be sold. It needed to be defended. It needed to be named. And once it became part of daily life, it needed a story people could repeat. Tesla could create astonishing things, but he did not always control the stories that formed around them. He had the gift of seeing systems before they existed in metal. He could imagine motors, currents, fields, and networks with a clarity that seemed almost unreal to those around him. But memory does not always belong to the person who sees first. Often it belongs to the person who builds the company, secures the contract, wins the case, captures the market, or appears most clearly in the public mind. This is why Tesla's life feels so haunting. He was not simply unknown. At several points he was famous. He gave lectures that astonished audiences. He stood in rooms where electricity leapt and glowed around him. He helped shape the system of alternating current power that would transform modern civilization. His name appeared in newspapers and scientific circles. He was not a hidden figure working in total silence, unseen by his age. And still, by the end of his life, he had drifted toward the margins of the very future he had helped create. To understand how that happened, we have to begin with the world around him, not only with the man himself. The late 19th century was an age of invention, but it was also an age of ownership. A discovery did not remain pure for long. Once an idea showed commercial promise, it moved into offices, ledgers, patents, stock deals, manufacturing plants, legal disputes, and public campaigns. A machine could begin as a private vision, but if it succeeded, it soon belonged to a network of forces larger than the inventor. Electricity made this especially true. It was invisible, powerful, and frightening. People could see its effects, but not the force itself. It could light a room, drive a motor, kill a person, transmit a message, or seem to animate the air. For the public, electricity was both miracle and threat. For businessmen, it was a new empire waiting to be built. For inventors, it was a field of wonder. For cities, it promised a future where night itself could be managed. In that atmosphere, credit became unstable. The person who discovered a principle was not always the person who made it practical. The person who made it practical was not always the person who made it profitable. The person who made it profitable was not always the person the public remembered. Invention became a chain, and each link in the chain could claim a different kind of ownership. Tesla's tragedy lives inside that chain. His greatest ideas were not small private curiosities. They were systems. They needed infrastructure to become visible. Alternating current power needed generators, transformers, motors, transmission lines, contracts, and utilities. Wireless communication needed receivers, transmitters, tuning networks, financing, and public proof. A dream of sending power or messages across the world needed not only scientific imagination, but an entire civilization willing to believe and pay before the results were fully secure. Tesla often had the first kind of power, the inner vision. Others often had the second kind, the machinery of execution and memory. That difference would shape his entire life. It is tempting to turn this into a story of villains and victims, because that version is easier to hold in the mind. Edison becomes the thief of credit. Marconi becomes the man who took radio. Morgan becomes the financier who abandoned the dream. Westinghouse becomes the company that carried Tesla's current into the world, while the inventor himself remained vulnerable. There are pieces of truth in some of these tensions, but the full story is more human and more difficult. Edison did not merely steal attention. He built an institution around invention. He understood publicity organization and the power of a laboratory that could turn individual creativity into a repeatable system. Westinghouse did not simply absorb Tesla's work. He helped make alternating current real at an industrial scale. Marconi did not invent wireless communication out of nothing, but he became one of the men who proved it to the world in a way institutions could recognize. Morgan did not create Tesla's ambition, but his money revealed how dependent even the largest vision could be on the patience of capital. Tesla stood among these men, but he was not like them. He could be elegant, disciplined, theatrical, proud, generous, difficult, visionary, and impractical. He could speak of technology with a kind of spiritual vastness, as if machines were not merely tools, but extensions of nature's hidden order. He could also make decisions that weakened his own position. He sometimes trusted brilliance more than business. He sometimes preferred the scale of the dream to the smaller steps that might have secured it. And as his ambitions grew, the distance between what he imagined and what others were willing to fund grew wider. That distance is important because Tesla was not forgotten only by enemies. He was also failed by the way modern technological memory works. We remember names through structures that repeat them. A company name endures, a product name endures, a prize endures, a laboratory endures, a textbook line endures, a court decision endures. A popular story told often enough endures. But a solitary inventor, especially one who loses control of his patents, his finances, and his public credibility, can become strangely vulnerable even when the work itself survives. The modern world does not always remember origins, it remembers systems. By the early 20th century, electricity no longer needed to feel miraculous. That was part of Tesla's victory and part of his disappearance. The more deeply electrical power entered daily life, the less people had to think about the minds that made it possible. A lamp was no longer a wonder. A motor was no longer a revelation. A signal crossing distance was no longer a miracle. These things became utilities, then habits, then background. The current was everywhere, but the story of the current became simplified, divided, and attached to the names most easily preserved. Tesla's name did not vanish completely. It moved in and out of public attention. Scientists and engineers knew important parts of his work. Certain honors came to him. Admirers continued to speak of him. But the secure place he might have held in the public imagination slipped away during his own lifetime. By his later years, he was often seen less as the architect of a future and more as a relic of an earlier age, a brilliant but eccentric figure still issuing grand claims while the world moved on through institutions stronger than he was. There is something especially painful about that. Tesla did not watch his ideas fail in the ordinary sense. Many of them succeeded or helped make success possible. The world did become electric. Power did travel across distances. Motors did drive modern industry. Wireless technologies did reshape communication. Automation and remote control did become part of the future. The world moved toward many of the horizons he had imagined, but it did not always carry him with it. This is one reason Tesla's story has grown so powerful in modern culture. People sense a pattern in it that extends beyond one inventor. They see the fear that imagination can be used without being honored. They see the possibility that a person may help create something vast and still lose control over how it is remembered. They see a world where credit does not always flow toward the source, but toward power, timing, money institutions, and narrative. That feeling explains why Tesla became after death more than a historical inventor. He became a kind of emotional figure. The genius overlooked, the dreamer exploited the mind too advanced for its age. But this myth, while understandable, can become another kind of distortion. It can make Tesla seem as if he invented everything alone, as if all rivals were frauds, as if every failed project was suppressed rather than incomplete, as if every missing proof hides a conspiracy. In trying to rescue him from neglect, the myth can sometimes carry him away from history. The quieter truth is stronger. Tesla was a real man, not a flawless prophet. His achievements were real, and so were his limitations. He was undercredited in significant ways, but he also lived in fields where many people were working at once. He saw possibilities earlier than most, but he did not always build the institutions needed to hold them. He changed the imagination of electricity, but he could not always translate wonder into durable ownership. That is the contradiction this documentary follows, not the simple question of who stole from Tesla, but the deeper question of how credit moves once an invention leaves the mind that first conceived it. Does it belong to the inventor who saw the principle, to the engineer who made it reliable, to the company that manufactured it, to the investor who made it possible, to the public figure who demonstrated it most successfully, or to the history that later chooses which name to repeat? In Tesla's life, all of these questions keep returning. They return in the rivalry with Edison, where invention meets reputation. They return in the alliance with Westinghouse, where a brilliant system becomes industrial power. They return in the dazzling lecture halls, where electricity becomes spectacle. They return at Wardenclyffe, where a tower built for the future falls silent before the world is ready to believe. They return in the story of radio, where several paths of discovery converge, and one name reaches public memory more clearly than others. And they return finally in the image of Tesla, alone in New York, surrounded by a civilization that had become electric. It is easy to imagine that room as pure defeat, but that would be too simple. Outside those hotel walls, the modern world was still carrying traces of him. They were not always labeled with his name. They did not always pay him back. They did not always defend his reputation. But they were there, hidden in the hum of motors, the logic of alternating current, the glow of lamps, the dream of wireless connection, and the belief that invisible forces could be made to serve human life. Perhaps that is the most haunting form of remembrance, to be present everywhere, but not always recognized. Before Tesla became the lonely figure of legend, before his name was argued over by admirers, skeptics, historians, and mythmakers, there was first a young mind trying to understand electricity, not as a set of isolated devices, but as movement rhythm and hidden order. Long before the courtrooms, corporations, towers, and accusations, there was the private act of imagining a machine so clearly that it seemed to run inside the mind before it existed in the world. To see how that kind of mind was formed, we have to leave the glowing city behind and travel back to a smaller, darker place where a child began learning how to build before touching metal. Before Nikola Tesla became a name argued over in courtrooms, newspapers, laboratories, and memory, he was a child in a small village where the modern electrical age had not yet arrived. Smiljan, where he was born in 1856, belonged then to the Austrian Empire, far from the industrial cities that would later glow with electric light. The world around him was still shaped by weather animals, church bells, family routines, darkness after sunset, and the slow rhythm of rural life. This is where the first contradiction begins. Tesla would become one of the men most closely associated with invisible forces, motors, currents, and signals crossing distance. Yet his earliest world was not a world of machines in the modern sense. It was a world where imagination had room to expand into silence, where natural forces were felt before they were measured, and where the line between inner vision and outer reality could feel unusually alive. Tesla's father, Milutin, was a Serbian Orthodox priest, a man of memory, language, and discipline. His mother, Duka, had no formal technical education, but Tesla later credited her with a remarkable gift for making tools and household devices. In that family background, one can already sense two forces that would later meet inside him: the verbal, almost spiritual world of ideas and the practical world of objects made by hand. He was not raised inside a factory, and that matters. He did not first meet invention as a corporate process, a laboratory routine, or a patent claim. He met it as a kind of mental and manual ingenuity, something that could begin in necessity and take shape through attention. The household device, the improvised tool, the remembered phrase, the image held clearly in the mind. These were small things. But for Tesla, small things could become patterns. Later in life, he described having an unusually vivid visual imagination. Whether every detail of his recollections can be taken exactly as stated is less important than the pattern they reveal. Tesla believed that he could picture devices internally with such clarity that he did not always need to build early models in the ordinary trial and error way. He would imagine a machine, let it run in his mind, examine where it wore down, and adjust it before any metal had been cut. This is one of the most important keys to understanding him. Tesla's genius was not only that he had ideas. Many inventors had ideas. His gift was that he could inhabit a system before it existed. He could think of movement energy fields and machinery as if they were already present, as if the invisible design had only to be translated into the visible world. But a gift like that can be both powerful and dangerous. It can produce astonishing confidence. It can allow a mind to move faster than workshops, investors, and other engineers can follow. It can also make the physical world feel slow, resistant, even disappointing. If a machine already runs perfectly in the imagination, the compromises required to build it, fund it, manufacture it, and persuade others of its value may feel almost secondary. Tesla's childhood was marked by sensitivity, intensity, and episodes that he later described as strange flashes of vision. He wrote of images appearing before him with great force, sometimes interfering with his perception of the world around him. Modern readers should be careful here. It is easy to turn these memories into diagnosis, and that would be too confident. What can be said more safely is that Tesla understood his own mind as unusually vivid, sometimes overwhelming, and deeply tied to visual experience. That inner life gave him a special relationship with electricity long before he fully mastered its science. Electricity was invisible but active. It could be felt through effects rather than seen directly. It could leap shock, attract repel glow, and move through hidden paths. For someone drawn to unseen order, electricity was not just another technical subject. It was a language of forces waiting to be understood. As Tesla grew older, education pulled him toward that language more formally. He studied in Karlovac, where he encountered physics demonstrations that deeply impressed him. The sight of electrical apparatus sparks and controlled forces seems to have opened a door. Here was nature made visible through experiment. Here was something that could be reasoned about, shaped, and perhaps one day commanded. He later attended the Polytechnic Institute in Graz, where he studied engineering. Graz was not the final destination, and his formal academic path was troubled and incomplete, but the period mattered. It placed him in contact with machines, mathematical methods, and the technical debates of his age. It also brought him face to face with one of the problems that would define his life, the electric motor. At the time, motors that used direct current often depended on commutators and brushes parts that switched current mechanically and created friction, sparking wear and inefficiency. To many engineers, these were ordinary difficulties to be managed. To Tesla, they represented something deeper, a kind of inelegance in the machine. He wanted motion without that mechanical violence rotation created by the action of fields rather than by constant physical switching. The problem lodged itself in him. The idea of a motor without the troublesome commutator did not arrive as a simple solution one afternoon and then vanish. It became a question that followed him across cities and years. How could electricity produce smooth rotation without the old mechanical interruptions? How could a field itself be made to turn? This question is technical, but the feeling behind it is almost poetic. Tesla was looking for motion created not by pushing from the outside, but by arranging invisible forces so that movement seemed to arise naturally from within the system. He was trying to make electricity behave less like a series of shocks and more like a rotating presence. After Graz, his path was uneven. He spent time in Prague, though not in the neat, completed way that later myth might prefer. Like many young men of talent and difficulty, he was still searching for the place where his mind could become useful to the world. His formal education had given him tools, but not yet a life. That life began to take clearer shape in the working world of Central Europe. In Budapest, he worked in connection with telegraph and telephone systems, technologies that were themselves changing how people understood distance. Signals could travel faster than bodies. Voices could be carried through wires. Information could move through invisible channels, translated into electrical pulses, and restored into human meaning somewhere else. For Tesla, this was not a minor environment. It placed him near the living edge of communication technology, where electricity was no longer merely a laboratory curiosity, but a carrier of presence across space. The world was beginning to shrink through wires. Messages no longer had to travel at the speed of horses, ships, or trains. A new kind of nervous system was being stretched across modern life. It was during this Budapest period that Tesla later remembered the insight that led to the rotating magnetic field. The story as he told it has the quality of legend. Walking in a park with a friend reciting lines from Goethe's Faust, he suddenly saw the solution in his mind. The rotating field appeared to him not as a vague idea, but as a working vision. He drew a diagram in the dust with a stick showing the principle of a motor that could turn without the old commutator. Whether we treat the scene as exact memory or as Tesla shaping his own origin story, it carries a deeper truth about how he understood invention. Discovery for him was not always a slow accumulation of parts on a bench. It could feel like the sudden unveiling of a hidden order. The machine had been waiting inside the problem, and the mind had only to see it clearly enough. The rotating magnetic field would become one of Tesla's most important contributions. In simple terms, it allowed alternating currents, properly arranged out of step with one another, to create a magnetic field that rotated. That rotating field could pull a motor's rotor into motion. The result was not just a new device, but the beginning of a system that made alternating current far more useful for industry. Yet at the moment of insight, nothing had been secured. No company had built it. No market had accepted it. No patent had defended it. No factory had manufactured it. The principle might be alive in Tesla's mind, but the world had not yet made room for it. This is one of the quietest but most important moments in his story. An invention can exist with great clarity to the inventor and still have no power in the world. Between mental certainty and historical recognition lies a long, uncertain passage. Tesla would spend much of his life crossing that passage, sometimes brilliantly, sometimes disastrously. After Budapest, he moved to Paris, where he worked for the Continental Edison Company. This was a crucial step. It brought him into the larger electrical industry, closer to practical engineering and closer to the American world that would soon define his career. Edison's name already represented more than a man. It represented a system, a method, a network of companies and technical ambition. In Paris, Tesla worked with electrical equipment and gained experience solving practical problems. He was no longer only a student of forces or a young thinker chasing an ideal motor. He was now inside the machinery of commercial electricity, where systems had to operate for real customers, where failures had costs, and where inventions were judged not by elegance alone, but by performance. Still, the contrast between Tesla's inner method and the industrial world around him remained. He could imagine machines with extraordinary precision, but industry did not reward imagination by itself. It rewarded delivery, reliability, documentation, money, persuasion, and institutional backing. The world Tesla was approaching would ask, not only is this brilliant, it would ask who owns it, who funds it, who manufactures it, who sells it, who defends it. Those questions were waiting for him in America. When Tesla crossed the Atlantic in 1884, he was not yet the mythic figure later generations would construct. He was a young immigrant engineer carrying experience, ambition, and ideas that had not fully found their stage. He arrived in a country hungry for invention, but also increasingly skilled at turning invention into business. New York was not Smiljan. It was not the inner theater of the mind. It was crowded, competitive, noisy, commercial, and impatient. The city into which he arrived was learning to become modern at extraordinary speed. Electric lighting was beginning to transform streets and interiors. Companies competed for technical advantage. Investors watched new systems for signs of profit. Newspapers turned inventors into public figures. A new kind of fame was forming around men who could seem to command nature itself. Tesla entered this world with a mind trained to see invisible systems. But America would test a different ability, whether he could attach those systems to power in the social sense, not only the electrical one. Could he persuade? Could he protect his claims? Could he survive inside another man's institution? Could he turn private certainty into public authority? At first, the path led to Thomas Edison. That meeting has often been turned into a simple collision of opposites, and in some ways it was. Tesla, elegant and theoretical, came with the vision of alternating currents and motors. Edison, practical and relentless, had built his reputation through experiment, commercial instinct, and an organized invention factory. One man seemed to live first in the completed image. The other built through persistence, testing, and institutional force. But to leave it at that would make the story too neat. Edison's world was not merely crude practicality. It was a model of modern invention. It showed that in the age of electricity, genius could be organized, multiplied, publicized, and owned. A laboratory could become more than a workplace. It could become a machine for producing reputation. Tesla had not yet learned how powerful that machine could be. His early life had prepared him to imagine the future with almost frightening clarity. It had given him discipline, intensity, technical ambition, and a relationship with invisible forces that few could match. It had given him the rotating magnetic field, or at least the mental foundation from which that invention would emerge. But it had not fully prepared him for a world where an idea's survival depended on more than whether it was true. The child from Smiljan, the student haunted by elegant motion, the young engineer in Budapest and Paris had learned to build before touching metal. Now he was entering a different kind of workshop, one where reputations were built, companies were wired together, and credit itself could become a form of machinery. And in that machinery, Tesla would soon discover that seeing the future was only the beginning. When Tesla arrived in New York in 1884, he entered a city that seemed to be remaking itself through force, speed, smoke, and light. The streets were crowded with horses, carts, workers, cables, shop fronts, and the noise of a country that believed the future could be built if only enough capital, labor, and ambition were brought together. America did not greet invention as a private revelation. It wanted invention to become a system, a business, a public fact. Thomas Edison already understood this world in a way Tesla did not. By the time Tesla came into his orbit, Edison was more than an inventor. He was a name, a brand, a public figure, and the center of an organized method for turning problems into patents, patents into products, and products into reputation. Around him was not only brilliance, but machinery. Assistants, investors, workshops, newspapers, customers, and a growing electrical enterprise. This is what Tesla encountered when he entered Edison's world. It was not simply the meeting of two minds. It was the meeting of two different ideas of what invention was supposed to be. Tesla carried within him the image of rotating fields, elegant motors, and electrical systems that seemed to arise whole in the mind. Edison's world was built on trial modification, persistence, commercial pressure, and a practical willingness to keep testing until something could be sold. The familiar story often turns this moment into a dramatic collision between genius and stubbornness, between alternating current and direct current, between the dreamer and the businessman. There is some truth in the contrast, but it becomes misleading if made too simple. Edison was not merely a man who failed to understand Tesla. He represented a new kind of power in modern invention, the power to surround an idea with organization until the organization itself became part of the invention. Edison's direct current system was already being used for electric lighting. It required generators, wiring, meters, lamps, maintenance crews, and customers close enough to the source of power to make the system practical. It was imperfect, limited in distance, and difficult to scale in the way alternating current eventually would. But it existed in the world. It had users. It had infrastructure. It had a name people recognized. Tesla's vision of alternating current, by contrast, still had the quality of something waiting to be fully born. He could see its elegance. He understood that alternating currents could be transformed to higher or lower voltages, making long-distance transmission more practical. He understood that a properly designed alternating system could drive motors without the old sparking commutators that troubled direct current machines. But insight alone did not command the streets of New York. Inside Edison's organization, Tesla worked on practical electrical problems. The exact details of every early episode have been retold so many times that legend and memory sometimes press against the historical record. One story, often repeated, says Tesla expected a large payment for improving Edison's machines and felt betrayed when the promise was treated as a joke. Whether every part of that account can be fixed with certainty matters less than what the story reveals about the atmosphere around him. Tesla believed his work had a kind of intellectual and moral value that should be recognized. Edison's world operated through bargaining hierarchy, utility, and results. It was a painful mismatch. Tesla was capable of intense labor, but he was not built to remain long inside another man's system. The more he worked under Edison, the clearer the difference became. Edison's approach accepted friction as part of the process. Try one material, then another. Test, fail, revise, repeat. Tesla admired efficiency and elegance. He wanted the principle that would make the whole machine feel inevitable. This difference was not only technical, it was almost philosophical. Edison's genius moved through accumulation, through thousands of trials gathered into a working product. Tesla's imagination moved through internal completion, through an almost visual certainty that a system could be perfected before it was physically assembled. Each method had strength. Each method had weakness. But in the industrial world of New York, Edison's method had one enormous advantage. It already had a structure around it. That structure mattered because the late 19th century was creating a new public image of the inventor. The inventor was no longer only a solitary thinker or a craftsman working quietly at a bench. He could become a national figure, a hero of newspapers, a promise to investors, a symbol of progress. Edison understood this perhaps better than any inventor of his generation. His laboratory did not only produce devices, it produced stories about invention itself. The public liked those stories. They liked the image of tireless experiment, of night work, of obstacles overcome by practical genius. They liked inventions they could see and touch, the lamp that glowed the phonograph, that spoke the system, that entered homes and businesses. Edison's reputation grew because his work could be packaged into visible miracles and repeated in a language ordinary people understood. He became in the public mind the man who made the future useful. Tesla's future was harder to describe. A rotating magnetic field could transform industry, but it could not be held in the hand like a glowing bulb. Alternating current was powerful, but also abstract and frightening to many people. The beauty of a polyphase system was real, yet it belonged to a world of fields, phases, motors, and transmission distances. Tesla's work often required explanation before wonder could fully arrive. That put him at a disadvantage in the machinery of reputation. The public memory of invention rarely preserves complexity well. It prefers a face, a scene, a phrase, a visible object. Edison offered all of those. Tesla offered something more elusive, an invisible order that made machines move. When Tesla left Edison's employment, he did not step immediately into triumph. That is important to remember. The later legend can make it seem as if the young inventor simply walked away from misunderstanding and into destiny. In reality, his first steps outside Edison's world were uncertain. He entered business arrangements that did not give him lasting control. He worked on electric lighting ventures, including arc lighting, and found again that technical ability did not automatically translate into ownership. The experience exposed a pattern that would return throughout his life. Tesla could create value, but value did not always remain with him. Investors, my investors and partners could see promise in his skill, but their interests were not the same as his. A company could use his inventions while leaving him financially exposed. The law might recognize a patent, but a patent still needed money behind it, management around it, and strategy to defend it. At one point, Tesla found himself far from the grand future he had imagined, taking work that later accounts describe as manual labor, even digging ditches for electrical projects. The image is almost too symbolic. A man who had conceived motors in his mind reduced to physical labor in the city where electricity was becoming an empire. It should not be overplayed as melodrama, but it shows how fragile an inventor could be when separated from institutional power. This fragility did not mean Tesla lacked confidence. If anything, he had an intense belief in the rightness of his own ideas. But confidence is not the same as protection. In the American electrical world, ideas moved quickly toward ownership. A man without stable backing could be brilliant and still precarious. He could know the future and still have no secure place in it. Edison's world had taught Tesla something by opposition. It showed him that invention needed a surrounding machine, and it showed him the danger of being inside someone else's machine. Yet Tesla's response was not to become another Edison. He did not build a large, durable institution around himself. He kept seeking patrons, partners, and moments of recognition that would allow his ideas to stand on their own force. This made his career dazzling at times and dangerously vulnerable at others. The conflict between direct current and alternating current was beginning to sharpen around these very questions. Direct current had an installed base and a famous champion. Alternating current had technical advantages for long-distance power, but it also faced fear, misunderstanding, and opposition. The debate was not merely about electricity. It was about which system would define the new electrical civilization and whose names would be attached to that definition. Edison, by position and instinct, defended the system in which his companies were invested. Alternating current threatened more than a technical preference. It threatened an infrastructure, a business model, and a reputation built around direct current lighting. In public battles over technology, safety often becomes part of the argument, and alternating current's dangers were emphasized in ways that shaped public fear. Electricity itself was still mysterious enough that fear could become a commercial weapon. Tesla stood on the other side of that future, but not yet as its secure owner. His alternating current ideas needed a champion with resources. They needed a company able to manufacture, promote, defend, and install them. Without that, they could remain elegant, even brilliant, but incomplete as history. The age was not waiting for the most beautiful principle, it was waiting for the system that could win. This is where the question of credit becomes more subtle. If Edison's name endured, it was not only because he took attention from others. It endured because he built a world in which attention could be captured and repeated. He attached invention to organization. He made the laboratory itself part of his legend. He understood that the public does not automatically remember the origin of an idea. It remembers the person whose name is built into the story around it. Tesla did not yet have such a story. He had flashes of reputation, technical advocates, and extraordinary ideas, but he was still searching for the arrangement that would let those ideas enter the world at scale. His time with Edison had revealed both the promise and the danger of modern invention. It could magnify a mind, but only if that mind was connected to the right machinery. Otherwise, it could swallow the work and leave the inventor standing outside the gate. The tragedy is that Tesla learned this lesson without fully becoming able to use it. He understood more and more that great electrical systems required more than imagination. But his own temperament kept pulling him back toward the purity of the idea, toward the next vision, toward the larger possibility just beyond the practical step. He wanted to transform the world, not merely manage a company. He wanted to reveal nature's hidden order, not spend his life tending the machinery of reputation. Yet reputation was already becoming one of the most powerful machines of the modern age. In Edison's world, Tesla had seen how a name could become attached to light itself. He had seen how invention could be organized, publicized, defended, and made repeatable. He had also felt what it meant to be a brilliant outsider inside a system that did not belong to him. When he left that world, he carried both resentment and knowledge, both ambition and warning. The next stage of his life would test whether his own vision could find a structure strong enough to carry it. Alternating current still needed more than a mind. It needed patents. It needed motors. It needed investors. It needed someone willing to challenge Edison's electrical empire, not with an idea alone, but with factories, contracts, generators, and wires stretched across distance. That someone would be George Westinghouse, and with him, Tesla's current would finally begin to move from imagination into infrastructure. A current can move through a wire without caring whose name is attached to it. It does not know the inventor, the investor, the company, or the courtroom. It only follows the conditions given to it, rising and falling, reversing direction, carrying energy through copper and iron toward whatever machine waits at the other end. But human memory is not like current. It does not flow automatically toward the source. It is guided, interrupted, transformed, and sometimes redirected by power of another kind. By the time Tesla's alternating current system began moving toward the world, the question was no longer only whether it worked. The deeper question was whether any invention, however brilliant, could survive without a company strong enough to carry it. Tesla had already seen what happened inside Edison's world. He had seen a laboratory become a reputation, and a reputation become a commercial force. He had learned painfully that a beautiful idea could remain fragile if it had no institution around it. Now his own ideas were reaching the point where they had to leave the private space of imagination and enter the harsher weather of industry. The invention at the center was his system of alternating current power built around the rotating magnetic field and the polyphase motor. To the modern listener, alternating current may sound ordinary, almost invisible in its familiarity. It is the kind of electricity that arrives without ceremony when a lamp is switched on, when a refrigerator hums in the kitchen, when elevators rise, when factories turn, when cities glow after sunset. But in Tesla's time, it was not yet the background of life. It was a contested future. Direct current had a powerful advocate in Edison and an existing place in early electric lighting systems. It worked especially over short distances, and it was already tied to companies' installations and public confidence. Alternating current promised something larger. Because its voltage could be changed more easily with transformers, it could travel at higher voltage over long distances, then be reduced for safer use near homes, businesses, and machines. It was a way of imagining electricity not as a local service clustered around small generating stations, but as a network stretching across distance. Yet that promise needed more than explanation. It needed motors that could make alternating current useful beyond lighting. It needed patents that could be defended. It needed manufacturing. It needed public demonstrations that could overcome fear. It needed someone with the courage and money to challenge Edison's growing electrical order. That person was George Westinghouse. Westinghouse was not Tesla's opposite in the same way Edison was. He was not simply another rival inventor standing across from him in the public imagination. He was a businessman, engineer, and industrialist, with the practical instinct to see that an electrical system was valuable only if it could be made reliable, sold, installed, and scaled. Where Tesla saw the elegance of the current and the motor, Westinghouse saw a possible infrastructure. Their meeting changed Tesla's life because it gave his ideas something they had lacked: industrial force. In 1888, Westinghouse acquired rights to Tesla's alternating current patents, including the polyphase motor system. For Tesla, it was a moment of recognition. His work, which had lived first as an image of invisible rotation inside the mind, now had a powerful company behind it. The future, he imagined, had found a vehicle large enough to move through the world. But the moment also carried the central tension of his life. Once an invention enters a company, it gains strength, but it also begins to belong to a story larger than the inventor. It becomes part of contracts, equipment, factories, engineering teams, marketing claims, and financial risk. It becomes a system, and systems tend to remember themselves. Tesla's alternating current system did not become world-changing because Tesla alone proclaimed it. It became world-changing because it entered a battle already underway over how modern cities would be powered. Westinghouse needed Tesla's patents to compete. Tesla needed Westinghouse's machinery to make his vision real. Their alliance was one of the rare moments when Tesla's imagination and industrial necessity seemed to meet. The War of the Currents has often been told as a struggle between two men, Tesla and Edison, alternating current and direct current, the elegant future against the stubborn past. But the real conflict was wider, heavier, and more institutional. It involved companies, investors, engineers, city governments, safety fears, patents, and the public's uneasy relationship with electricity itself. Edison's system was not merely a technical choice. It was tied to capital already spent, businesses already formed, and a public identity carefully built around electric light. Alternating current threatened that world because it changed the scale of possibility. A city did not have to be served only by nearby generators. Power could be produced farther away and carried across distance. Natural forces, such as falling water, could be transformed into electricity and sent to places that needed it. Motors could be made to run with fewer of the sparking wearing parts that had troubled earlier machines. Electricity could become less like a scattered urban novelty and more like the nervous system of modern life. That scale made alternating current attractive, but it also made it frightening. Higher voltages were dangerous. Public understanding was limited. Opponents of alternating current use that fear, sometimes aggressively, to cast it as a deadly force unsuitable for ordinary life. In an age when electricity was still mysterious, the boundary between legitimate safety concern and commercial propaganda could become blurred. The public saw wires overhead, heard stories of accidents, and sensed that something powerful had entered the streets before everyone fully understood it. Tesla was not the main public fighter in every part of this war. That role belonged largely to companies and their spokesmen, to newspapers and business interests, to men managing systems and reputations. This itself reveals something important. Tesla's invention was at the center of the future, being fought over, but the fight was being conducted by institutions. The current carried his vision. The battle carried other names. Still, Tesla did appear before the public in ways that mattered. He could demonstrate alternating current not only as a technical system, but as a controlled force. He had a rare ability to turn electrical theory into atmosphere. In lectures, he allowed audiences to see lamps glow without ordinary wires, tubes shine with strange light, sparks leap through darkness, and high-frequency currents behave in ways that seem to soften the terror of electricity into wonder. He was not merely arguing that alternating current could work. He was teaching people to imagine electricity differently. This was one of Tesla's great powers. He could make the invisible feel present. Yet a demonstration, however beautiful, is not the same as a utility. Wonder opens the mind, but infrastructure changes the world. For alternating current to win, it had to move beyond lecture halls and into contracts. It had to light real buildings, power real machines, and survive real financial pressure. This is where Westinghouse became essential. Tesla could give the age a new electrical principle. Westinghouse could try to give that principle a market. The 1893 World's Columbian Exposition in Chicago became one of the great public turning points. The fair itself was a city of spectacle, built to display progress, empire, machinery, architecture, and national confidence. At night, electric light transformed it into something almost dreamlike. Buildings glowed against the darkness. Walkways, domes, and facades appeared under a radiance that many visitors had never experienced on such a scale. Electricity became not only a technology, but a vision of civilization. Westinghouse, using alternating current, helped light the fair. Tesla's system stood behind the spectacle, even if the crowd did not always understand the technical lineage behind what they saw. For many visitors, the fair was proof that electric light belonged to the future. It was safe enough to enter public imagination, powerful enough to illuminate a vast space, and beautiful enough to become symbolic. The darkness of the old century seemed to be receding under a new artificial dawn. For Tesla, this should have been the kind of triumph that secures a name forever. His ideas were no longer private diagrams or disputed claims. They were present in light itself, shining across one of the most visible stages in the world. Yet even here, the question of credit remained complicated. The fair remembered Westinghouse. It remembered modern electricity. It remembered progress. Tesla's contribution was real, but it was also embedded within a larger industrial achievement. That is how infrastructure works. It makes the individual source harder to isolate because success depends on so many hands. Engineers, manufacturers, financiers, installers, operators, and promoters all become part of the same glow. A motor that once existed in Tesla's mind becomes a component inside a system so large that no single person can stand visibly inside every part of it. The next great symbol was Niagara Falls. For generations, Niagara had represented natural power in its raw form. Water height, thunder mist, and the overwhelming force of a river falling through stone. To harness it for electricity was to change the meaning of power itself. It suggested that nature's grandeur could be converted into an invisible current carried across distance and made to serve cities and factories. It was one of the clearest images of the modern age taking shape. The Niagara Project helped confirm alternating current at industrial scale. Power generated there could be transmitted to Buffalo, proving that electricity did not have to remain close to its source. The waterfall became more than a spectacle of nature. It became a generator of urban life. In the story of electrical modernity, this was a turning point with almost mythic force. Tesla's connection to Niagara had deep symbolic weight. He had dreamed of using the forces of nature, not merely burning fuel in small local stations. Alternating current made such a dream practical in a way direct current could not. At Niagara, the principle became landscape. Water fell, turbines, turned generators, produced current, and energy traveled outward toward human use. The invisible field Tesla had imagined became part of a continent's physical transformation. But again, triumph did not resolve the question of ownership. The more successful alternating current became the less it belonged to the intimate story of one mind. It became a public utility, an industrial standard, a commercial victory, an engineering system. The public did not live inside patent claims or technical lectures. They lived inside the results. They saw light. They used power. They learned company names, station names, city names, and the broad story of progress. Tesla was there and not there. This is one of the most difficult parts of his legacy to hold clearly. Westinghouse did not simply take Tesla's future away from him. Without Westinghouse, Tesla's alternating current work may not have entered the world with such force. The company gave his ideas a body large enough to move through history, and yet because that body was corporate and industrial, it could never preserve Tesla's authorship in the pure way admirers might later wish. The relationship between Tesla and Westinghouse also reminds us that invention often requires surrender. To see an idea become real, the inventor may have to place it into the hands of others. He may have to accept contracts, compromise as manufacturing changes, financial pressures, and the fact that the world will encounter the invention through a system rather than through the inventor's private vision. Success itself can become a form of loss. For Tesla, the financial side of this success remained uneasy. Stories surrounding his royalty arrangements with Westinghouse have often been repeated with a tone of noble sacrifice, Tesla giving up claims to help the company survive. The details can be told in different ways, and the surrounding mythology should be handled carefully. But the broader pattern is clear enough. Tesla's ability to profit securely from his own work was far less durable than the system his work helped create. That contrast would follow him. Alternating current would continue to spread. Westinghouse would remain one of the great names in electrical industry. Edison's name would remain attached to the public mythology of invention. The electrical age would keep expanding. Tesla would be honored, admired, and consulted, but he would also remain strangely exposed, a man whose most successful ideas had already passed into machinery too large for him to control. The irony is almost quiet enough to miss. Tesla's current succeeded because it could travel farther than the older systems. But as it traveled, his name did not always travel with it. This is not because his contribution was minor. It was because the world into which it entered had its own rules for remembering. A working grid does not narrate its origins each time power flows through it. A factory motor does not tell the story of the rotating magnetic field. A city street glowing at night does not explain patent transfers, lectures, rivalries, or the young man who once saw invisible motion in his mind. Utility erases wonder by making it dependable, and yet there is a dignity in that erasure too. The deepest success of a technology is that it becomes ordinary. When a society no longer pauses before switching on a light, the invention has fully entered life. Tesla helped make that possible. His tragedy was that ordinary life is not always grateful. It absorbs miracles and forgets to ask whose hands first shaped them. By the mid-1890s, Tesla seemed to stand at a remarkable height. Alternating current had moved from theory to spectacle to infrastructure. He had broken out of Edison's shadow, found an industrial ally, and seen his principles help illuminate a fair and harness a waterfall. The future had not rejected him. For a time, it seemed to confirm him, but confirmation can be dangerous for a mind like Tesla's. The success of alternating current did not make him smaller in ambition. It made the possible world seem even wider. If invisible currents could light cities and move power across distance, what else might they do? Could electricity pass through the air? Could it make tubes glow without wires? Could it carry signals, commands, even energy itself across empty space? Could the planet become not only powered, but connected? The company had helped carry Tesla's current into the world. Now, Tesla's imagination began moving toward forces no company could easily contain. The next stage of his life would not be defined by the steady machinery of infrastructure, but by rooms filled with violet light coils hissing in darkness, glass tubes glowing in the hand, and audiences watching electricity behave as if the invisible had become theatrical. Alternating current had needed a company, but Tesla's next dreams would need something harder to secure belief. After alternating current had found its company, its contracts, and its place in the growing machinery of electrical civilization, Tesla might have chosen to become a more ordinary kind of successful inventor. He could have spent his years defending patents, improving motors, advising industry, and allowing the world to remember him as one of the architects of modern power. That path would have been safer. It might even have preserved him more securely. But Tesla's imagination did not rest easily inside what had already been proven. The success of alternating current seems to have opened a larger space in his mind. If invisible forces could be organized to spin a motor carry power across distance and light cities, then perhaps electricity was not merely a utility. Perhaps it was a deeper language of nature. Perhaps it could be shaped into light without wires, motion without touch, communication without visible connection, and someday maybe power transmitted through the very body of the earth and air. This is where Tesla's story changes its texture. The previous stage was full of companies, contracts, public battles, and industrial scale. Now the scene narrows again into rooms, stages, coils, lamps, sparks, glass tubes, and spectators trying to understand what they were seeing. Tesla did not simply explain electricity. He arranged it before an audience until it seemed to reveal itself. In lecture halls and laboratories, he became a performer of invisible forces. He stood near coils that sent out brilliant electrical discharges. He held tubes that glowed without being connected by ordinary wires. He filled darkened rooms with strange violet light. To modernize, some of these demonstrations might look like early electrical theater, beautiful but familiar. To many people at the time, they belonged close to the edge of the impossible. That edge mattered. Tesla was working in a period when electricity still had not settled into the dull reliability of the wall socket. It was still new enough to frighten, amaze, and confuse. It could kill a worker in the streetlight, a mansion ring, a telephone drive, a motor, or leap through the air in a crackling arc. People could see what it did, but they could not see the thing itself. This made electricity unusually suited to spectacle. Tesla understood that better than most. His demonstrations were not empty showmanship, even when they were theatrical. They were a way of making invisible principles emotionally real. A listener might struggle to follow an explanation of high-frequency alternating currents resonance induction or wireless transmission. But if a tube glowed in the hand, if light appeared without the usual wire, if sparks moved through darkness like living branches, then the idea entered the imagination before it entered the intellect. The Tesla coil became one of the central instruments of this world. Developed in the early 1890s, it allowed him to produce high-voltage, high-frequency currents that behaved very differently from the low-frequency power systems used for ordinary lighting and motors. In technical terms, it belonged to a family of resonant transformer circuits. In the atmosphere of Tesla's demonstrations, it seemed almost like a doorway into a hidden layer of nature. With these coils, Tesla explored effects that blurred the boundary between science and wonder. Lamps could be made to glow under conditions that suggested power might be transmitted without conventional conductors. Electrical discharges could be lengthened, shaped, and intensified. Currents that would have been dangerous under one set of conditions could, under another, pass over the body in spectacular demonstrations that looked terrifying yet were carefully controlled. This was not the stable world of the power station. It was electricity as atmosphere, and that difference is important for the question of credit. Alternating current had needed a company because it had to become infrastructure. But these high-frequency experiments needed something else first. They needed belief. They needed audiences willing to imagine that the strange lights before them were not just tricks, but glimpses of coming technologies. Tesla had to persuade people that wonder itself could be a map. For a time, he succeeded. His lectures in the 1890s helped make him one of the most fascinating electrical figures of his age. He was elegant, intense, and unusually gifted at presenting himself as a man in conversation with forces ordinary people could barely name. He did not appear merely as a mechanic or businessman. He appeared as someone who had entered the invisible world and returned carrying evidence. Yet spectacle is a delicate form of power. It can make a name shine, but it can also make a reputation unstable. The public may admire a demonstration without understanding its limits. Investors may be drawn to the promise without grasping the distance between an experiment and a commercial system. Admirers may turn the inventor into a magician. Critics may dismiss him as theatrical. Wonder can open doors, but it does not always build the floor beneath them. Tesla's own language sometimes heightened this instability. He spoke in vast terms about the future of energy communication and human progress. He imagined a world in which distance would be conquered by electrical means, where signals and perhaps power itself might move through natural media. These ideas were not born from emptiness. They grew out of real experiments, real observations, and real technical ambition. But they often reached beyond what he could immediately prove in a form the market or scientific community could accept. That reaching beyond was part of his greatness and part of his vulnerability. In these years, Tesla also explored phenomena that touched the early history of X-rays. He experimented with tubes, high voltage, and radiant effects, and he noticed strange photographic results before and around the period when Wilhelm Röntgen's discovery made X-rays famous. Tesla later contributed observations about the dangers of such radiation. This part of his work is useful not because it makes him the sole hidden origin of another discovery, but because it shows how often he was operating near the frontier, where several paths of science were opening at once. The frontier is never as clean as later memory wants it to be. Discoveries overlap. Several people see related effects. One publishes first, another understands a different part, a third builds an instrument, a fourth finds the public demonstration that fixes the discovery in history. Tesla often stood close to these moments, sometimes centrally, sometimes at an angle, sometimes with insight that did not become the recognized name attached to the field. Again and again, the pattern returns. To be early is not the same as to be remembered. To see deeply is not the same as to secure credit. To demonstrate something astonishing is not always to build the institution that preserves it. The most striking example of this stage came in 1898 at Madison Square Garden, when Tesla demonstrated a radio-controlled boat. The object itself was small compared with power stations, waterfalls, and towers, but as a vision of the future, it was extraordinary. Before an audience, he showed a boat moving and responding to commands without a visible connection. It could turn stop-start and obey signals sent through space. For a modern listener, radio control is familiar. Remote devices are everywhere. Machines receive signals constantly. Drones, robots, satellites, toys, vehicles, and household systems all belong to a world in which command at a distance has become ordinary. But in 1898, the sight of a moving boat guided without wires unsettled the categories available to the public. Some observers wondered whether it was controlled by hidden mechanisms, trained animals, or even some form of mind reading. They were not foolish. They were trying to understand an invention before the world had built a language around it. Tesla called the device a kind of automaton. That word carried a future inside it. The boat was not only a clever demonstration of wireless control, it suggested machines that could respond to signals act at a distance, and perhaps one day operate without human presence inside them. In that moment, Tesla stood near the beginning of ideas that would later touch robotics, remote warfare automation, and wireless command systems. But once more, he had shown a future before the world was prepared to organize itself around it. The demonstration was astonishing, but it did not immediately become an industry under Tesla's control. It did not give him a lasting company, a fleet of machines, or a secure financial base. It was a door opening briefly, then closing before enough people understood what lay beyond it. This is one of the strange sorrows of Tesla's career. He often arrived at the threshold of coming worlds. He touched them, illuminated them, sometimes named them, sometimes dramatized them. But the age around him did not always know which threshold mattered most. A glowing tube, a wireless signal, a resonant coil, a controlled boat, each could seem like a marvel. Among other marvels, one more wonder in a time already crowded with invention. The 19th century was becoming the 20th, and the air itself seemed full of new possibilities. Telephones carried voices. Telegraphs compressed distance. Electric lamps changed the night. Phonographs preserved sound. Cameras fixed images. Railroads and steamships altered the scale of movement. In such an age, even a brilliant demonstration could be swallowed by the general astonishment of progress. Tesla needed more than astonishment. He needed a path from demonstration to durable form. He needed the kind of institutional continuity that could turn a stage event into a commercial network, a patent into a defended empire, a public marvel into a repeated necessity. But his mind kept leaping ahead. Where others might have paused to build one technology into a business, Tesla often saw that technology as evidence for a still larger dream. His high-frequency work pointed toward wireless transmission. His glowing lamps suggested that power might not always need ordinary conductors. His experiments with resonance encouraged the hope that the Earth itself might take part in the movement of electrical energy. His controlled boat suggested a world of machines responding across distance. To Tesla, these were not isolated tricks. They were signs of a hidden unity, fragments of a larger electrical order waiting to be mastered. That sense of unity gave his work a rare grandeur. It also made him difficult to support. Investors tend to prefer a product, a market, a schedule, and a return. Tesla was increasingly offering a vision of planetary transformation. He could show pieces of it, sometimes brilliantly, but the whole remained vast, expensive, and uncertain. The more ambitious the dream became, the harder it was to translate into the practical language of capital. This is where the theater of invisible power begins to cast a shadow. The same demonstrations that made Tesla famous also encouraged him and others to believe that the next step might be just as dramatic as the last. If a tube could glow without ordinary wires in a room, perhaps power could cross a city. If power could cross a city, perhaps it could cross a continent. If signals could steer a boat across a basin, perhaps messages could move around the world. The imagination moves quickly along such lines. Engineering moves more slowly. Tesla's reputation in this period therefore became double-edged. To admirers, he was the man who saw what others could not. To skeptics, he risked becoming a man of magnificent claims and uncertain delivery. Both impressions could be drawn from the same facts. He had done astonishing things. He also promised futures that required more proof than he could easily provide. A calmer history must hold both truths at once. Tesla was not a fraud surrounded by sparks. He was a serious inventor, exploring real electrical phenomena at the edge of contemporary knowledge. But he was also not a magician who could leap from laboratory effect to global transformation without cost infrastructure or error. His tragedy lies partly in the space between those two realities. The public rooms of his demonstrations were filled with light, but the path ahead was already narrowing. For all their beauty, the glowing tubes and radio-controlled boat did not solve the problem that had followed him since Edison's laboratory. Who would own the future he was revealing? If he could not turn these marvels into lasting systems, others might later take pieces of the same future and build them under different names. If he spoke too grandly before proving enough, he risked weakening his credibility. If he waited too long, the age might move ahead without him. By the end of this period, Tesla's attention was being pulled toward a vision larger than any lecture hall. He no longer wanted only to demonstrate that electricity could move strangely through a room. He wanted to show that energy and information could move through the world. He began to imagine not just devices, but a planetary system communication across oceans, signals sent without wires, perhaps even power made available at a distance. The theater was becoming too small for the dream. In the next act of Tesla's life, the sparks would no longer be confined to a stage. They would rise into the open air of Colorado, crash through the night in artificial lightning, and gather at last around a tower on Long Island, built to speak to the world. It would be the boldest attempt of his career to turn invisible power into a global system. It would also become the place where wonder money, uncertainty, and memory began to break apart. There are dreams that can be tested on a table, under glass, with wires, coils, meters, and a few careful witnesses. There are other dreams that require a landscape. They need space, money, trust, time, and the permission of the world before they can even begin to prove themselves. By the end of the 1890s, Nikola Tesla was no longer satisfied with lighting tubes in a room or making sparks leap across a lecture hall. He wanted to know whether the Earth itself could become part of an electrical system. The path toward Wardenclyffe did not begin with the tower. It began in the wide air of Colorado Springs, where Tesla arrived in 1899 to continue experiments that New York could no longer contain. The place offered open space, high altitude, and a kind of atmospheric drama that suited the scale of his thinking. There, far from the dense commercial machinery of the city, he built an experimental station and turned again toward the invisible forces that had always drawn him forward. In Colorado, electricity seemed to escape the smallness of ordinary apparatus. Tesla produced enormous discharges of artificial lightning that filled the night with light and sound. He explored resonance, high-voltage wireless transmission, and the possibility that electrical energy might move through the earth and atmosphere in ways that could be used deliberately. The experiments were real ambitious and technically serious, but they also belonged to the borderland where measurement, interpretation, and imagination pressed closely against one another. For Tesla, this borderland was not a weakness. It was where the future lived before other people could see it. He believed that the planet itself might be made to carry signals and perhaps power if only the right frequencies, apparatus, and methods could be found. The idea had a grandeur that made ordinary business language feel almost too small. He was no longer thinking only of stations, wires, and motors. He was thinking of a world connected through natural media, as if the earth could become an electrical instrument. This was the dream that would gather itself on Long Island. Wardenclyffe was meant to be more than a laboratory. It was to be the first visible piece of a larger system, a place from which Tesla hoped to transmit messages, signals, and perhaps energy across great distances. The site near Shoreham, New York, offered land access and enough distance from Manhattan to build something large without being entirely removed from the capital and publicity of the city. At its center rose a tower strange and commanding, like a question built out of timber and steel. The tower looked as if it were waiting for a voice. It is tempting to see Wardenclyffe only as a ruin, because that is what memory has made of it. A failed tower, a lost dream, a monument to a future that did not arrive. But when Tesla began, it was not a ruin. It was a promise. It carried the confidence of a man who had already helped bring alternating current into the world, who had stood before audiences and made invisible power glow, who had demonstrated wireless control before many people understood what wireless control could mean. Yet this time, the scale was different. A glowing tube in a lecture hall could persuade through wonder. A motor could be tested, measured, improved, sold. Wardenclyffe demanded faith before proof could become ordinary. It required investors to believe in a system that was not yet a commercial network, and in a man whose imagination was moving faster than his ability to translate every part of it into business certainty. J.P. Morgan became the crucial figure in this stage of Tesla's life. Morgan's backing gave the project financial legitimacy, but it also placed the dream inside the world of capital. Tesla might have thought in currents resonance and planetary systems, but Morgan thought in returns, control markets, and strategic advantage. Between those two languages lay one of the deepest tensions of Wardenclyffe. Tesla wanted to build something vast. Morgan wanted to know what the vast thing would be worth. At first, wireless communication offered a clearer commercial promise than wireless power. Messages could be imagined as a business. They could compete with cables, telegraphy, and the growing hunger for rapid communication across oceans. If Tesla could send signals across distance without wires, the value was easier to understand. The world already knew what messages were. It only needed to be convinced that they could move through the air reliably and profitably. But Tesla's vision did not remain small enough to be safe. He kept seeing beyond communication toward the transmission of energy itself. He imagined not only messages crossing distance, but power made available through a global electrical system. To him, these possibilities were connected. To investors, they could look like expansion, uncertainty, and risk. The more magnificent the dream became, the harder it was to define. This is where Wardenclyffe becomes the emotional center of Tesla's story. It gathered every force that had shaped his life: brilliance, ambition, showmanship, technical originality, financial dependence, and the recurring difficulty of holding ownership over a future not yet built. The tower was an invention, but it was also an argument. It said that the world could be organized differently, that wires might not be the final form of connection, that distance itself could be conquered by electrical means. Still, an argument built in wood and metal must eventually answer practical questions. What exactly would it deliver? How soon? At what cost? With what proof? Under whose control? Tesla's mind was comfortable in the full architecture of the dream, but the people paying for it needed stages, guarantees, and visible progress. The tower could inspire awe, but awe alone could not keep construction paid. At the same time, the wireless world was not waiting quietly for Tesla. Other inventors and experimenters were moving. Guglielmo Marconi, in particular, was building his own path through wireless telegraphy, one that emphasized communication more narrowly and practically. Marconi's work did not contain the same grand dream of global wireless power, but it had something investors and institutions could understand more easily: signals sent, received, publicized, and turned into a recognizable service. When Marconi achieved celebrated wireless successes, especially across long distances, the pressure on Tesla increased. The public and financial imagination began to attach wireless communication to another name. Tesla could argue with reason that his own work had anticipated and enabled important principles in the field. But public credit often follows the demonstration that arrives at the right time in the right form, not the broader vision that may have existed earlier, but remained harder to complete. This was not simply a story of one man taking from another. It was a story of different strategies, meeting a world that rewarded one more quickly. Marconi narrowed the problem. Tesla expanded it. Marconi made wireless communication legible as a business and a public achievement. Tesla was trying to make wireless into a planetary system of energy and information. One path was smaller, but easier to recognize. The other was grander, but more vulnerable to doubt. Wardenclyffe began to suffer under that doubt. Money tightened. Costs rose. Tesla's explanations did not always reassure those who needed reassurance. The project's purpose, at least in the eyes of backers, seemed to shift or widen beyond the original promise. Morgan became less willing to continue support. Without sustained capital, the tower could not become what Tesla imagined. The place built to speak across the world remained trapped in a silence of unfinished work. That silence must have been devastating. For Tesla, Wardenclyffe was not merely a failed investment. It was a test of whether his deepest electrical vision could become real outside the mind and laboratory. Alternating current had found a company. The theater of invisible power had found audiences. But Wardenclyffe needed a civilization willing to believe in a future before that future could defend itself. It did not receive enough belief. The tragedy of Wardenclyffe is sharper because it was not obviously foolish in every part. Wireless communication was real. Remote control was real. High-frequency experimentation was real. The desire to transmit across distance without wires belonged to the actual technological movement of the age. Tesla was not dreaming from emptiness. He was extending lines of research that mattered. But the leap from experiment to global system was enormous, and he could not carry it alone. A calmer history should avoid two easy mistakes. The first is to say that Wardenclyffe failed only because financiers lacked imagination or because rivals stole Tesla's rightful future. The second is to say that the failure proves the dream had no substance. Neither answer is sufficient. Wardenclyffe failed in the difficult space between real possibility and unproven scale, between technical insight and commercial proof, between a visionary's confidence and an investor's patience. Tesla himself made that space more difficult. He could be secretive, proud, and reluctant to reduce his ideas into forms others could easily test or own. He feared being copied, yet needed support. He wanted control, yet depended on money. He spoke of vast systems, yet had to persuade men who wanted practical returns. Every great dream needs translation. At Wardenclyffe, Tesla's translation was never enough. The tower remained standing, but its meaning changed. It had been built as an instrument of connection, a structure meant to send something outward into the world. Instead, it became an image of interruption. The future had reached upward, then stopped. Around it gathered unpaid bills, abandoned hopes, and the quiet humiliation of a man whose imagination had again outrun the machinery that might have protected him. There is a particular loneliness in an unfinished machine. A broken device has at least lived through use. An obsolete device has served its age and been replaced. But an unfinished machine remains suspended between possibility and failure. It never fully proves itself, and so it can never fully defend itself. Wardenclyffe became that kind of object. It could be read as a symbol of genius impracticality, betrayal ambition, or loss, depending on what the observer already believed about Tesla. For Tesla, the loss was not only technical, it was reputational. When a grand project collapses, it changes the way later claims are heard. Earlier wonders may begin to look theatrical. Future promises may be met with less patience. The same public that once marveled at glowing tubes and wireless control could begin to see him as a man of beautiful impossibilities. The shift was gradual but dangerous. Meanwhile, the world continued moving toward wireless communication through other hands. Signals crossed water, systems improved, companies formed, governments and navies took notice. The language of wireless became tied increasingly to practical communication, not to Tesla's more expansive dream of power and planetary resonance. History was choosing the version of the future that could be built first. This is one of the central lessons of Wardenclyffe. The future does not always belong to the largest imagination. Sometimes it belongs to the version of an idea that can be made reliable soon enough, simple enough, and profitable enough for institutions to adopt. Tesla had imagined a larger world, but others were building narrower pieces of it in forms that could survive. And survival is one of the hidden engines of credit, an idea that survives inside a company, a network, a service, or a military system, is repeated again and again. Each repetition strengthens the name attached to it. A failed or unfinished project may remain more beautiful, more ambitious, even more prophetic, but it does not enter daily life in the same way. It becomes a legend rather than an institution. Legends can return powerfully after death, but they rarely pay the living inventor's bills. Wardenclyffe also reveals the sorrow of being early in the wrong way. Tesla was early in understanding that wireless would matter profoundly. He was early in treating distance as something electrical systems could overcome. He was early in imagining a connected planet. But he may have been too expansive too soon, reaching for a total system when the world was prepared to finance narrower communication. To arrive early is not always enough. One must arrive in a form history can use. By the time the project declined, Tesla had lost more than a tower. He had lost one of his last great chances to bind his name permanently to the next electrical age. Alternating current had already passed into infrastructure. High-frequency demonstrations had passed into memory and partial influence. Wireless communication was now moving under other names. Wardenclyffe was supposed to gather these lines and make them Teslas again, not only as principles, but as a living system. Instead, it became the place where the lines broke. The tower was eventually dismantled, but even before its physical destruction, it had fallen silent, in another sense. It no longer spoke convincingly to the people who controlled money, publicity, and institutional belief. Tesla could still imagine what it meant. Admirers could still see in it a lost future. But the world around him had begun attaching wireless progress elsewhere. That is why Wardenclyffe should not be remembered only as failure. It was also a revelation. It showed with painful clarity what Tesla's life had been moving toward all along. The man who could see machines before touching metal had reached the point where imagination alone could no longer carry him. The man who had helped power cities now needed financial and public power of another kind. Without it, even a tower built to speak to the world could remain unheard. As Wardenclyffe faded, wireless did not fade with it. Messages still crossed distance. Radio continued developing. Courts, patents, companies, and public memory would later return to the question of who had truly reached that future first. But for Tesla, the most painful part had already happened. The dream had moved on without securely carrying his name at its center. The tower tried to speak to the world. Other names would be heard more clearly. Wireless did not die with Wardenclyffe. That is what made the silence of the tower so painful. If Tesla's dream had failed because the whole idea of wireless transmission was empty, the story would have been simpler. The tower could have been remembered as a beautiful mistake, one more grand invention that reached beyond what nature allowed. But the world did not turn away from wireless. It moved toward it. Signals continued crossing distance. Ship stations, governments, engineers, and companies began to understand that communication without wires was not fantasy. It was the next frontier. The tragedy was that this frontier did not organize itself around Tesla. By the time Wardenclyffe was losing money and confidence, Guglielmo Marconi was becoming one of the most visible names in wireless telegraphy. Marconi's path was different from Tesla's. He did not try to build a planetary system of wireless power. He narrowed the problem. He focused on sending messages. He built apparatus-tested distances, improved reception, attracted backers, and presented wireless as something the world could understand immediately. A way to communicate where wires could not easily go. That clarity mattered. A wireless message was easier to sell than a wireless civilization. A ship at sea receiving a signal had obvious value. A government, a navy, a newspaper, or an investor could understand the importance of information moving across water and distance. Marconi's system did not have to promise the whole future at once. It only had to prove that a message could arrive. Tesla, by contrast, had imagined wireless as part of a much larger order. In his mind, communication and power were connected to a deeper understanding of the Earth, resonance frequency, and transmission through natural media. His vision was magnificent, but magnificence can blur the first practical step. While Tesla looked toward a vast system, Marconi built a recognizable service. History often rewards the recognizable service. This does not mean Marconi worked in an empty field, and it does not mean Tesla's claims were imaginary. Wireless emerged from a crowded landscape of experiment and theory. James Clerk Maxwell had given the mathematical foundation for electromagnetic waves. Heinrich Hertz had demonstrated them experimentally. Oliver Lodge, John Stone, Alexander Popov, Tesla, Marconi, and others all contributed to the developing world of wireless signaling. No honest history can reduce the field to one heroic inventor acting alone. But public memory rarely holds crowded landscapes well. It prefers a clear line, a first achievement, a name that can be repeated. Marconi became that name for wireless telegraphy in much of the public imagination. He had the right kind of demonstrations at the right time attached to practical use and institutional support. He did not need to be the only origin of the technology to become its most famous face. For Tesla, this was a familiar wound in a new form. Once again, he had worked near the center of a future that did not fully preserve him as its owner. He had patented important methods. He had demonstrated wireless control. He had experimented with high-frequency currents and resonant circuits. He had spoken of transmitting signals across distance before wireless became a public industry. Yet when the world began attaching a name to radio and wireless telegraphy, it often reached for Marconi first. The pain was not only personal vanity, it was structural. Credit is not simply praise. Credit decides who receives investment, who is trusted, who is quoted, who is invited into institutions whose patents are respected, whose failures are forgiven, and whose story enters textbooks. A name attached to success becomes easier to support. A name associated with unfinished towers and enormous claims becomes easier to doubt. Marconi's rise showed how quickly a field can harden around a public narrative. Once newspapers, investors, governments, and institutions begin repeating a name in connection with a technology, that repetition becomes a form of reality. It does not settle every technical question, but it shapes what ordinary people believe has happened. The public does not read every patent. It remembers the figure standing beside the achievement. Tesla knew enough to challenge this. He believed that Marconi had used principles and inventions that Tesla had established earlier. In later legal and historical disputes, this question would become complicated, technical, and often misunderstood. Some admirers would simplify it into a single sentence: Tesla invented radio and Marconi stole it. Some skeptics would simplify it in the opposite direction, treating Tesla as irrelevant to radio's development. Neither simplification is enough. The truth is more intricate and more revealing. Radio was not one invention in the way a single tool might be. It was a system of discoveries and refinements. Oscillators, antennas, tuned circuits, detectors, transmitters, receivers, grounding systems, practical signaling methods, and the ability to make all of it work reliably across distance. Tesla had major claims in parts of that story. So did others. Marconi's strength was not that he created every element from nothing. His strength was that he assembled, adapted, demonstrated, and commercialized wireless communication in a way the world could use and recognize. This is exactly the problem that had haunted Tesla since Edison's laboratory. What counts as invention when a future is made from overlapping pieces? Is it the first principle, the first patent, the first working system, the first public success, the first commercial network? The name that survives because it was repeated by institutions. In the field of radio, those questions do not have a simple emotional answer. The 1943 decision by the United States Supreme Court would later become central to Tesla's modern reputation. The court invalidated certain Marconi patent claims, recognizing that important earlier work by Tesla and others had anticipated key elements. To Tesla's admirers, this decision has often felt like a late correction, a legal echo arriving after the man himself could no longer hear it. And in one sense, it was a meaningful recognition that Tesla's contributions had been deeper than public memory often allowed. But even that recognition must be handled carefully. The decision did not turn the entire history of radio into a single act of theft reversed by the court. It dealt with specific patent claims and prior art. It showed that Marconi's claims were not as original in every respect as his public fame might suggest. It placed Tesla back into a technical lineage from which he had too often been simplified away. But it did not change the fact that during the crucial years of public recognition, Marconi had already become the man most clearly associated with wireless success. That is the cruelty of delayed credit. It can correct a record without repairing a life. By 1943, the year of the Supreme Court decision, Tesla was already dead. The legal recognition came too late to restore money confidence position or the public authority he had lost. It could help later historians reconsider his place, but it could not send him back to Wardenclyffe with renewed support. It could not make investors believe earlier. It could not undo decades in which wireless communication had advanced under other names. This late recognition deepens the documentary's central question. If history eventually admits that a person contributed more than was remembered, does that restore ownership? Or does it merely reveal how much was lost in the years when recognition might have mattered? Tesla's case suggests that credit has a timing of its own. To be recognized too late is not the same as being recognized in life. Living credit brings opportunity. Posthumous credit brings symbolism. The first can fund laboratories, defend patents, attract collaborators, and shape institutions. The second can inspire books, arguments, statues, and myths. Both matter, but they do not do the same work. Marconi's recognition, by contrast, arrived while he could still use it. It strengthened his companies, his authority, and his place in public memory. The Nobel Prize he shared in 1909 with Carl Ferdinand Braun further solidified his standing as a central figure in wireless telegraphy. Awards do not create invention, but they do organize memory. They tell the world where to look. They make a complicated field feel as if it has a few official names. Tesla did not receive that kind of anchoring in the radio story during his life. He received admiration, yes, and occasional honor, but not the durable institutional attachment that turns a person into the accepted face of a technology. His name drifted through the field as a claim, a dispute, a remembered contribution, a grievance, a missing piece. Marconi's name stood more firmly in the public architecture. It would be unfair, though, to imagine Marconi as merely a thief walking into Tesla's abandoned room. That version satisfies anger, but it weakens the history. Marconi was persistent, practical, and effective. He understood the importance of demonstration range communication service and public proof. He made wireless useful in ways that institutions could adopt. In the world of technology, usefulness made visible at the right moment carries enormous force. Tesla's deeper tragedy is that he often possessed a wider vision than the men who received clearer credit. But wider vision was not always what the world rewarded first. A broad dream may contain more of the future, but a narrower application can win the present. Once it wins the present, it begins shaping the past. People then look backward from the successful system and assume that the public face of that system must have been its true origin. This is how memory bends. It bends toward the working network, the famous demonstration, the investor-backed company, the courtroom victory, the newspaper headline, the prize ceremony, the textbook sentence. It bends toward anything that can be repeated easily. Tesla's work, especially in wireless, was more difficult to repeat in a simple form. Was he the inventor of radio? A pioneer of wireless, a visionary, whose ideas overlapped with later systems? A wronged claimant in specific patent disputes? A brilliant experimenter whose larger dreams outran practical proof? The honest answer requires more than one sentence. But myths prefer one sentence. This is why Tesla's modern reputation often swings between extremes. In one version, he is the suppressed father of nearly every modern technology robbed by lesser men. In another, he is reduced to an eccentric dreamer whose admirers exaggerate everything. Both versions are tempting because both are easy. The real Tesla stands in the more difficult space between them. He was genuinely central to important electrical futures. He was also one figure in a crowded, competitive international age of invention. To see him clearly, we have to resist the comfort of simple restoration. Giving Tesla credit does not require taking every achievement away from others. It requires understanding how invention often works. Many minds approaching similar problems, some seeing principles early, some building devices, some creating markets, some receiving fame, some being forgotten until later. Credit is not a single lamp that can shine on only one person. But history often behaves as if it were. In Tesla's life, this behavior became a wound. He could look at wireless progress and see traces of his own work. He could see principles he had explored moving through systems he did not control. He could see another name becoming the one the public remembered. For a man already bruised by failed financing and unfinished dreams, this was more than professional disappointment. It was the feeling of being separated from his own future, and yet the future kept arriving. Radio would grow far beyond the early wireless telegraphy of Marconi's age. It would carry voices, music, news, war reports, entertainment, propaganda, distress signals, and private wonder across invisible space. It would enter ships, homes, armies, cars, factories, and eventually the atmosphere of ordinary life. Later, still wireless principles would become part of a much larger world of communication control, broadcasting, and connection. Some of this future echoed Tesla's imagination, though not always in the form he expected. The question is not whether Tesla saw everything exactly as it came to pass. He did not. No one does. The question is why his way of seeing so often approached the edge of what later became ordinary, while his personal life moved toward insecurity and isolation. He could sense directions before they had stable names. But sensing a direction is not the same as becoming the institution that carries it forward. That distinction became more painful with age. Younger Tesla had entered America with ideas still waiting for their stage. Middle Tesla had stood before audiences, lit rooms, and seen his alternating current system help transform the world. But the older Tesla increasingly found himself arguing with memory itself. He had to insist on priority. He had to defend the seriousness of visions that had not fully materialized. He had to watch other men become monuments while he became in public eyes more difficult to place. There is a sadness in having to explain that you were there first. The need to insist can itself weaken a reputation. A living inventor who says "I saw this before them" may be telling the truth, but the statement can sound bitter if the world has already chosen its hero. Institutions prefer confidence that arrives with success. They are less patient with claims that arrive after the money prizes and headlines have moved elsewhere. Tesla's voice in such moments could sound like a warning from a future that had already been renamed. Still, the record did not erase him completely. Engineers, historians, and later courts preserved enough of the evidence for his role to re-emerge. His patents, lectures, demonstrations, and technical writings remained. The problem was not total disappearance. It was uneven remembrance. Tesla was visible in fragments, brilliant in some accounts, marginal in others, mythic in later retellings, and never quite settled. That unsettled quality is part of why his story continues to trouble us. If he had been fully forgotten, the injustice would feel clear. If he had been fully honored, the tragedy would be smaller. Instead, he remained half-lit famous, but not always for the right reasons. Credited, but not always at the right time. Admired, but not always supported. Mythologized, but not always understood. The radio story gathers all of this into one field of invisible signals. Somewhere inside it are Tesla's genuine contributions, Marconi's practical achievements, Lodge's experiments, Stone's work, the mathematical foundations laid by others, the institutions that rewarded certain names, and the public memory that simplified the rest. It is not a clean story of theft. It is a story of convergence, conflict, priority, and the strange fact that the future often arrives through many doors, though history later paints only one of them gold. For Tesla, by the time some of those doors were reopened, life had narrowed. The great projects were behind him. The laboratories were gone. Wardenclyffe had fallen into silence. The electrical age he helped imagine was now proceeding without needing his permission, his presence, or even his full recognition. Others had reached parts of the future first in the eyes of the world, even when he had seen some of those futures earlier in principle. What remains after that is not only a question about radio, it is a question about the fate of the inventor when the age of invention moves on. Tesla would live long enough to see his name flicker between admiration and ridicule, honor and neglect, science and speculation. He would become more solitary, more symbolic, and in some ways more difficult for his own time to understand. The world around him would become increasingly electrical, increasingly wireless, increasingly close to dreams he once described. But the man himself would move into hotel rooms, memories, public claims, and the company of birds. The future had not forgotten how to use electricity. It had not forgotten how to send signals through the air. It had not forgotten how to turn invisible forces into daily life. It had only become uncertain what to do with Nikola Tesla. By the time Nikola Tesla entered the last decades of his life, the world had become more like the future he once imagined, but less willing to see him as one of its central architects. Electricity was no longer a marvel reserved for Fair's laboratories and wealthy interiors. It was spreading into ordinary life, becoming the quiet background of streets, factories, homes, communication systems, and machines. The invisible forces that had once made audiences gasp in lecture halls were becoming dependable enough to be ignored. That was part of Tesla's triumph and part of his disappearance. A technology becomes most powerful when it no longer feels miraculous. The lamp glows, the motor turns, the signal arrives, and the user does not pause to think about the generations of thought, labor, argument, risk, and failure that made it possible. The future Tesla helped open did not need to speak his name each time it functioned. For Tesla himself, that silence became harder to escape. The great age of his public ascent had passed. The alternating current victories were now part of industrial history. The dazzling demonstrations of high-frequency electricity belonged to another moment when audiences still gathered in wonder before glowing tubes and violent sparks. Wardenclyffe had failed to become the planetary instrument he imagined. Wireless communication had moved forward under names that institutions and the public could more easily recognize. He was not forgotten all at once. That is too simple and too dramatic. Tesla continued to receive attention, interviews, honors, and occasional admiration. In 1917, he received the Edison Medal, a complicated honor, given the history between the two men and the symbolic weight of Edison's name. But honors can arrive with a strange coldness when they do not restore the life that recognition failed to protect. A medal may acknowledge a past contribution, but it cannot rebuild a laboratory, reopen a lost tower, or return a career to the moment when credit might still have changed its direction. Tesla's later life unfolded in New York hotels, where the setting itself feels almost painfully suited to the story. A hotel room is not a home in the fullest sense. It is a temporary space made permanent by circumstance, a place designed for passing through, not for belonging. Tesla moved through such rooms as the city outside continued to shine with electric life. Around him stood one of the great modern cities of the world, wired, lit, vertical, restless, and full of machines. Yet he himself had become more isolated from the machinery of progress. The image is easy to romanticize, and many retellings have done exactly that. Tesla alone, feeding pigeons, speaking of lost inventions, dreaming beyond a world too small to understand him. There is sadness in that picture, but also danger. If we make it too beautiful, we risk turning real loneliness into a decorative legend. Tesla's final years were not simply a poetic scene. They were marked by financial insecurity, fading institutional support, increasing eccentricity, and the painful gap between his past achievements and his present condition. Still, the pigeons matter, because they reveal something human that the technical story alone cannot carry. Tesla had always lived with an unusual intensity of feeling discipline and sensitivity. In later years, his affection for pigeons, especially the famous accounts of one white pigeon he described with deep attachment, has often been used to make him seem strange. But perhaps it also shows the narrowing of his world. A man who had once addressed grand audiences and imagined signals crossing the planet found companionship in creatures that came and went quietly without contracts, investors, or disputes over credit. His public claims during these years became increasingly difficult for others to interpret. He spoke of new inventions, powerful beams, advanced systems, and possibilities that seemed to some listeners extraordinary and to others implausible. The world had changed around him. Physics had moved into new territories. Engineering had become more institutional and specialized. The age of the lone electrical showman standing between science and spectacle was giving way to larger laboratories, corporate research, and government-linked technologies. Tesla still spoke in the language of vast possibility. But now that language no longer had the same effect. Earlier in his life, grandeur had helped him draw attention to genuine new fields. Later, grandeur sometimes made him easier to dismiss. The difference was not only in Tesla, it was in the age. A young inventor promising a new electrical future can sound like a herald. An aging inventor without the resources to demonstrate his claims fully can sound like a relic, even when the mind behind the claims still carries traces of brilliance. This is one of the cruel rhythms of reputation. The same qualities that once seem visionary can later appear excessive if the surrounding conditions change. Confidence becomes stubbornness, secrecy becomes suspicion, ambition becomes impracticality. The refusal to think small once admired becomes evidence that a person no longer belongs to the practical world. Tesla had not become simple, but the world around him had become less patient with his particular kind of complexity. And yet he was never merely a faded eccentric. That is the other mistake. To reduce Tesla's late life to odd habits and grand claims is to let the final chapter obscure the earlier work. The aging man in the hotel room was also the man of the rotating magnetic field, the polyphase motor, alternating current, power, high-frequency experiments, wireless control, and public demonstrations that changed how people imagined electricity. His decline did not erase those achievements. It only made them harder for the public to hold together with the fragile figure he later became. When Tesla died in January 1943, the world was at war, and technology had taken on a scale of urgency he had long predicted in different forms. Communication power detection machinery and scientific research were now matters not only of progress, but of survival. The 20th century had become electrical, industrial, and increasingly invisible in its systems of force. In that world, Tesla's life ended quietly, far from the applause and ambition of his earlier decades. Then something strange began to happen. The man who had been unevenly remembered in life slowly returned after death, not only as an inventor, but as a symbol. This return did not happen in a single clean wave. Engineers and historians had always preserved serious parts of his record. The unit of magnetic flux density, the Tesla would later carry his name in scientific usage. Museums' biographies and technical histories revisited his work. Admirers gathered around the story of a genius who had seen too far ahead. Over time, especially as modern culture became fascinated by electricity, wireless technology outsiders, and suppressed brilliance, Tesla's image began to glow again. But posthumous memory is never pure restoration. It does not simply return the person as he was, it builds a new figure out of documents, longing, arguments, fragments, and the needs of later generations. Tesla became the misunderstood genius, the inventor wronged by Edison, the man cheated by Marconi, the prophet of wireless power, the saint of innovation, the lonely dreamer, whose ideas were too advanced for a greedy world. Some of this image grew from real injustice and real under-recognition. Some of it grew from exaggeration. The myth solved one problem and created another. It rescued Tesla from neglect, but sometimes replaced the historical man with a legend easier to love. In the mythic version Tesla invented, almost everything rivals become villains, failures become conspiracies, and uncertainty disappears. That version may feel emotionally satisfying, especially to anyone who has ever feared being overlooked. But it does not truly honor Tesla. It turns him into a weapon against history rather than a person within it. The historical Tesla is more difficult and more moving. He was brilliant, but not infallible. He was undercredited in important ways, but he did not work alone in an empty universe of invention. He saw astonishing possibilities, but not every possibility he imagined could be built in the way he described. He was exploited at times, but he also made choices that left him vulnerable. He deserved more recognition, yet the story of credit around him cannot be repaired by giving him credit for everything. To see Tesla clearly is to accept the tension. He was both visionary and impractical, both disciplined and difficult, both central to the electrical age and strangely outside the institutions that preserved it. He could attract wonder, but he could not always convert wonder into lasting power. He could imagine systems before they existed, but he did not always build the social systems that would keep his name attached to them. That may be the deepest answer to the question this documentary has been following. The future is not owned only by those who imagine it first. It is also owned by those who finance it, manufacture it, simplify it, defend it, publicize it, standardize it, and repeat its story until the repetition becomes memory. Tesla's tragedy was not only that others took credit, it was that credit itself moves through machinery he never fully controlled. Edison's machinery was the laboratory, the brand, the public identity of invention. Westinghouse's machinery was the company, the contract, the industrial system that made alternating current powerful enough to reshape the world. Marconi's machinery was practical communication, public demonstration, institutional recognition, and a name attached to wireless success at the right historical moment. Morgan's machinery was capital with all its patience and impatience. Tesla had a different machine, the inner theater of imagination, where motors turned before they existed and electricity seemed to reveal hidden order. That machine was extraordinary, but it was not always enough. Still, the late return of Tesla's name tells us something important about memory. History may be slow, incomplete, and unfair, but it is not always finished. Names can fade and re-emerge. Documents can be reread. Old patent disputes can be reconsidered. Myths can distort, but they can also point toward wounds that official memory left unresolved. Tesla's modern fame, even when exaggerated, carries a real emotional truth. Many people feel that the world did not repay him in proportion to what he gave it. The task is to rescue that truth without surrendering to fantasy. Tesla does not need to have invented every modern technology to matter. He does not need every rival to be a thief. He does not need every failed dream to be secretly successful. His actual life is already large enough. A young man from Smiljan who imagined machines with uncanny clarity crossed into the American electrical world, helped make alternating current, practical filled rooms with impossible light, demonstrated wireless control, tried to build a tower for a connected planet, and ended his life in a city humming with forces he had helped bring into being. That is more haunting than legend because it is human. The modern world often prefers invention stories with clean endings. A problem appears, a genius solves it. A name enters history, and progress moves forward. Tesla's life refuses that simplicity. It shows that invention is not a straight line from idea to glory. It is a passage through rivalry, capital misunderstanding, collaboration, publicity law failure, and time. It shows that a person can be right in one sense and still lose in another. It shows that the future can use someone's dream without fully protecting the dreamer. And it asks us to listen differently to the hum around us. Behind ordinary power, there are forgotten arguments. Behind a switch, there are battles over systems and standards. Behind wireless signals, there are crowded histories of overlapping insight. Behind every famous name, there are other names, some preserved, some dimmed, some waiting for a later age to notice them again. Tesla's story is not only about Tesla, it is about the way civilization remembers innovation after it has become too useful to seem mysterious. By the end, perhaps Tesla was neither fully forgotten nor properly remembered. He became something in between, a name lit unevenly by admiration, resentment, myth, and belated justice. During life, he could not secure the stable recognition that might have changed his final years. After death, he received a kind of radiance that sometimes illuminated him and sometimes blinded people to his real shape. That is why the image of Tesla alone in New York remains so powerful. Outside the hotel, the city glowed. Machines turned, signals moved. The electrical age continued without asking whether the man who had helped imagine it felt at home inside it. The current did not know his name. The lamps did not remember. The motors did not pause in gratitude. But memory is not a motor. It can return, however imperfectly, to the places where something was lost. Tesla's name returned too late to save the man, but not too late to trouble the story of progress. It reminds us that the future is not born cleanly, and it is not remembered fairly by accident. It must be looked at again with patience, with doubt, with gratitude, and with enough honesty to see both the brilliance and the cost. Somewhere beneath the ordinary glow of the modern world, Tesla remains present in that difficult way, not as a flawless prophet, not as a vanished ghost, but as a current still moving under the surface of memory. By the end of Tesla's life, the world no longer needed to understand him in order to use what he had helped set in motion. Electricity had left the lecture hall. It had entered walls, streets, factories, railways, telegraph rooms, radio towers, and ordinary homes. The invisible forces that once seemed theatrical in Tesla's hands had become part of daily life. People no longer had to marvel at them. They could simply switch them on. That may be the deepest sadness in his story. Tesla was not erased because his ideas were empty. He faded partly because his ideas became too large, too useful, and too widely absorbed to remain attached to one fragile human life. Some credit was lost in rivalry. Some was reshaped by patents and publicity. Some was carried away by men better suited to institutions, finance, and reputation. And some was blurred by Tesla himself by the scale of his dreams, the difficulty of proving them, and the loneliness of a mind that kept moving beyond what others were ready to build. Yet memory has a strange patience. Long after the laboratories closed, after Wardenclyffe fell silent, after the hotel rooms emptied, Tesla's name began to glow again. Not always accurately, and not always fairly, but with a force that suggests something unresolved still remains. Perhaps the real question is not whether history can return every piece of credit to its proper owner. It rarely can. The quieter question is whether we can learn to see invention more honestly, not as a single name carved into stone, but as a long passage from imagination to power, from power to industry, and from industry to memory. Tesla's life reminds us that the future is often first seen by people who do not fully survive its arrival. And somewhere inside the steady hum of the modern world, his dream is still there, not as myth alone, but as a current moving beneath the surface.